All right, this is midterm review number 1. I'm going to go through and I'm not going to give you the direct answers, but I'll kind of help you, give you some hints, maybe work out a separate example for each of these questions. So let's look at number 1. The question says the table below shows values for g of x. If g of x is a one-to-one function, what is the value of g negative 1 of negative 8? So keep in mind that that little negative 1 means inverse. Okay, so for question number 1, that really means inverse, and that means that the x and the y, or the x and the g of x, switch places. So I want to look not at negative 8 for the x value to give me my output. I want to look at that as a y value. So you're going to give me the x value when you plug in the y value of negative 8. Okay, question number 2. What's the inverse f inverse x of the function below? Well, inverses have the same rule. You want to switch x and y and solve for y. So I'll get you started and you can solve it out. Remember, f of x is y. So we would say y equals negative 3x plus 5 over 4. Then we're going to switch these two. So we'll say x equals negative 3y plus 5 divided by 4. We're going to solve. So what do we do to solve? We bring up the 4. So we say 4x equals negative 3y plus 5. Then we have to subtract the 5 and divide by the number in front of y. So if I subtract 5, I get 4x minus 5 equals negative 3y. And if I divide by negative 3, well, let's just divide by 3 first. And that'll leave me negative y. Now, we don't have that answer choice, but if I divide by negative 1, that's going to switch the signs of the 4x and the negative 5. So that's going to become negative and positive. So it's negative 4x plus 5 over 3. All right, for question 3, ignore these inequalities. Basically, the inequalities is saying what numbers you're allowed to plug in. And I can plug in numbers greater than or equal to negative 3 for this function because if I take the square root of a negative number, it won't allow me to give me an answer. So that's the only reason this inequality even exists. You know, you can put in negative 2, negative 3, and you'll get numbers 0 or greater. But if I put in negative 4, negative 4 plus 3 is negative 1. Can't square root negative 1. So that's the whole reason this is there. The inequalities here saying x is greater than 0, just saying I can only plug in numbers greater than 0 because I can't square root negative numbers. Okay, so ignore the inequalities. Just look at the function. Y equals the square root of x plus 3. I want to get the inverse. So again, switch the x and the y. How do you undo a square root? You square both sides. That's going to lift that square root off of the y plus 3. And then you solve it for y. All right, on this problem, it says, given the graph below, find f inverse x when x equals 4. This is not an x value if that says inverse. That's actually a y value. So we're not looking over here. We're looking at the y value and reporting the x value in this problem. Okay, now I didn't really get a chance to go over these very well during class, I'll admit. So I'm going to just kind of work with you on how to set that one up. This is composition, so g of f of x. We plug in one function for the other. I'm going to pause it so I can get a chance to write it out so you can see what you got to do. Okay, so the notation, that little circle, is implying that you're going to plug in the function f into the function g. So you really want to write it as g of f of x. You want to take that f of x, since that's on the inside, and you want to replace it with the x in 4x minus 1. So what's going to happen is you're going to write that 4x minus 1, but then the x is just going to become an open set of parentheses, and you're going to plug in the f function into that. So you're going to do that and distribute, work it out, and you'll have your answer. Okay, another problem kind of related to that is question 6. It says, which item is true of f of x and g of x? And they're talking about how their inverse is. What do you get when you plug in one function into the other? Do you get 1, 0, x, or negative x? So I went ahead and just made a function to kind of teach that to you, since I really don't think I did a good job of showing that during the semester. What you're going to do is you're going to take it doesn't matter which function, you're going to take one of the functions and you're going to place it with x. So if they're inverses of each other, which these two are, if I plug in the x plus 2 over 3 in place of this x here, and I actually work it out, what's going to happen is the 3 times x plus 2, that's going to be, well, actually the 3 and the 3 can just divide out. So that's going to cancel. And you're going to be left with x plus 2 minus 2. And, well, if I do 2 minus 2, I get x. X, that's the diagonal line. Do y'all remember on Desmos, when I showed you inverses, I did if you do 3x minus 2, and what was the inverse function? I believe it was x plus 2 over 3. They are reflected over the line y equals x. So x is the line of reflection. Actually, that's what, when you plug in one function over into the other, it's going to meet to form that diagonal line. So x is what you get when you plug in one function into the other, x. Okay, question 7. This is a piecewise function. The amount of money Sarah earns per week is modeled by the function w below, where h represents the number of hours Sarah works in a week. If Sarah worked a total of 41 hours last week, how much money did she earn? I'm not going to write anything out here, but look at these inequalities. H stands for the hour. And so if the hour is between 0 and is greater than 0 but less than or equal to 40, then I'd plug it into 8 times whatever amount of hours I have. So if it's 20 hours, then 8 times 20 would be $160. If it's 40 hours, it's still going to go into the top function because equal to means that it could be also 40. So 8 times 40 would be whatever, $320. But if I'm doing anything greater than 40, like 41, I want to plug it into the bottom function. So I'm going to plug in 41 into h minus 40 and work that out. 12 times 41 minus 40 plus 320. That will give me my answer. So you're going to substitute into that function. Okay, question 8 is a piecewise function again. We want to know what is the value f of 5 plus 8 f negative 4 minus f of 6. So we just got to identify where we're plugging in our numbers. 5 is, if we look at these inequalities, 5 is going to be into the middle one because 5 is equal to 5. So I want to plug in 5 into 2x plus 8. Negative 4, that's less than negative 2. So I want to plug in negative 4 into 3x squared minus 2x plus 4. And 6 is greater than 5. So I want to plug in 6 into 5x cubed minus 7x. Once I have those three numbers, then I'm going to do the following operations. I'm going to add this number to 8 times the number I get when I plug in negative 4. And then I'm going to subtract the number I get when I plug in 6. Okay, for question 9, the roots of a quadratic equation are 6 and 5 over 3. If one of the two factors of the equation is x minus 6, which expression could be a second factor? Well, x minus 6 gives you a 0 of 6. Zeros and roots are the same. So that's the factor for this. So what's going to give me a factor for 5 over 3? Well, you want to solve the equation. X equals 5 over 3 for 0. All right, well, how do I solve that? Well, I could do 3 times x equals 5. And then I want you to solve for 0. So what do you got to do to get this equal to 0? You got to move this over. Is it going to be adding 5 or subtracting 5? What's going to get you the 0? Remember that zeros and factors have opposite signs. In this last problem, the question says, which of the following functions is symmetric with the y-axis? Just graph it and think of the y-axis as a line of symmetry. All right, let me give you one answer that's not correct. X squared plus 3x minus 5. This is not symmetric with the y-axis because the y-axis is not splitting it in half. That vertex is shifted over. So it's not going to be this one. Let me give you an example that's not on here that would be symmetric. X squared. That's symmetric with the y-axis. X squared minus 9. That's symmetric because it didn't shift left or right. Okay, so the y-axis is the line of symmetry. All right, hopefully that explanation of these problems was helpful. I'd love for you to, I know I kind of basically gave you the answers to a few of them and kind of led you through to get most of them. I'm going to be a little less involved in the other ones, but I'll try to go over questions that are different. Okay, so like if you see repeated questions in the following reviews, then I'm not going to go over those, but I will have you refer to a previous question in another review or in your notes if you need to. All right, thanks.